Have you ever stopped to wonder what makes up the world around us? It's a question that might seem simple, but when you dive deeper, you'll find it's a fascinating exploration into the very essence of our universe. This essence is what we call matter. Everything we see, everything we touch, everything we interact with in our daily lives is made of matter. From the smallest grain of sand on a beach to the tallest skyscraper in a bustling city, from a drop of water to a gust of wind, all of it is matter. It's an incredible concept when you think about it. Matter exists in three fundamental states: solid, liquid, and gas. Each state has its unique properties, its own way of interacting with the world, and it's this interaction that shapes our reality. So, the air we breathe, the water we drink, and the chair you're sitting on, it's all matter. Now let's delve into the heart of matter with the kinetic theory. This theory, in essence, is about movement. It states that all matter is made up of tiny particles that are always in motion. Imagine a crowded dance floor. Each dancer represents a particle of matter. These dancers, or particles, are always moving, never truly at rest, just like particles in matter. This constant motion is what the kinetic theory is all about. Now, the way these particles move, fast or slow, close together or far apart, determines the state of matter they form. Let's illustrate this with some common experiences. Think about a block of ice. The particles in ice are like dancers moving slowly and staying close together, holding hands in a tight formation. This is similar to the particles in a solid state. They vibrate in place but don't move about freely because they're closely packed together. Now imagine the ice melting on a hot day. As the ice turns to water, the dancers speed up and start to move apart. They're no longer in a tight formation but moving more freely. This mirrors the particles in a liquid state. They're still close, but not as tightly packed as in a solid. They move with more freedom, sliding past each other. Finally, think about that water boiling and turning into steam. Now the dancers are moving very fast, spinning, twirling, and jumping all over the dance floor. They've spread out, no longer close together. This is how particles behave in a gas state. They move rapidly and are far apart from each other. So the kinetic theory helps us understand that the particles of matter are always moving. The speed and proximity of this motion determine whether matter is a solid, a liquid, or a gas. Therefore, the state of matter can change, but it is still matter, just with particles moving in a different way. Okay, let's take a moment to revisit what we've learned. We started by redefining our perspective, understanding that the world around us isn't just tangible stuff, but a magnificent realm of matter. Matter, in its essence, is anything that occupies space and has mass. It can exist in three primary states: solid, liquid, and gas, each with its unique characteristics and behaviors. Then, we delved into the kinetic theory of matter, a concept that brings life to our static view of the world. This theory suggests that all matter is composed of tiny particles that are constantly in motion. The speed and pattern of this motion depend on the state of matter, with particles in solids vibrating in place, particles in liquids sliding past each other, and particles in gases flying around freely. Remember, the world around us is a fascinating dance of particles in motion. That's the kinetic theory of matter. Before we wrap up, let's ponder on this. Every single thing that surrounds us, from the air we breathe to the ground we walk upon, is made up of matter. It's a fascinating thought, isn't it? That the world as we know it is a grand display of particles in different states of motion. We witness these changes in states of matter every day. When you boil water for your morning tea, it transforms from a liquid to a gas right before your eyes. In the winter, you might see puddles freeze overnight, turning from liquid to solid. These aren't just random occurrences. They are science in action, the kinetic theory of matter playing out in our everyday lives. We are, in essence, living in a constant science experiment. So the next time you see steam rising from a hot cup of coffee or feel the chill of an ice cube, remember, it's all a matter of particles in motion.